I'm Rob Stupplebeen with Optimal Device. We do design and analysis with the life sciences industry. One of the great things with the power of the portfolio is that you get access to all the different simulation tools that Dassault has. And I wanted to teach myself TOSCA for Topology Optimization, which is a method where you take geometry and you erode away the material where it's not needed. It's based off of bone biomechanics modeling, where the bone grows to where the loads are going to be focused. And trying to figure out what a good use case would be was I was looking at my lacrosse stick head, because I coach my son in lacrosse, and I noticed that we had this truss structure that was already in the design, which is exactly what most topology optimizations end up with, is that these trusses end up following the loads that are associated with the loading conditions. So I took this design, I calipered it up with my trusty calipers, and then brought it into CATIA, did some surface-based modeling to make the biggest, thickest design possible to give the topology optimization a design space to work with. And from there, TOSCA goes and erodes away the material. In Abacus, I applied 3 different orthogonal loads. I applied a load like that, a side load, and then a front load. And then scaled those loads to have it so there was a similar stress distribution on all of them so that the optimization would drive based on all 3 designed. Once I had that base Abacus model, I brought it into TOSCA, which is really just an extra little window in Abacus, so you don't have to use a new GUI. It's sitting right there under the topology optimization, and let it erode away the material. And the end results were something that was very similar to what you see here, where we've got truss structures, we've got holes, some of them are going diagonal in different directions. And what was really surprising is that I actually replicated where these openings happen near where the shaft enters the head. I'm interested in doing design of experiments to kind of show that for a defender, you want a very stiff, heavy head. For if you're doing offense, you want to be able to throw the ball fast, so you'd want a light head. So you'd get different design variants in the same design family. But this project was really just for fun, which I highly recommend that everyone goes out and dabbles, because we have access to some of the most fun tools, and people usually just do their day-to-day stuff with it.